Okay guys, today we're going to talk about simplifying complex fractions. So a complex fraction is a fraction, go figure, a fraction that contains a fraction. Contains a fraction in its numerator or its denominator. So another way to say this is it's a fraction within a fraction. All right, we're going to talk about two ways to be able to deal with these. The first, simplify the numerator and denominator by writing it as a single fraction, and then just do your division. So let's take a look at an example. 2x over 1/3. We'll go ahead and write this as a single fraction, so we'd go 2x over 1 divided by 1/3. Right, whole numbers you can always write over 1, so that's all we did right there. And then we follow the steps that we had previously, the idea of multiplying by the reciprocal or keep, change, flip. So we go 2x times, so 2x over 1 times 3 over 1, which is just going to give us 6x. Okay, so let's do another one, just super basic example. Just make sure you have the right idea here. Take 1/4, divide it by 2/5. Again, write this as a fraction divided by another fraction. Then we can do keep, change, flip. Again, multiply by the reciprocal. 1/4 times 5/2. Multiply that together, we get 5/8. Okay, so that's the first approach. Rewrite it as one fraction divided by another fraction, and then follow through the process that we've already learned for multiplying and dividing fractions. Method 2 is a little bit more intensive, but in some cases it might be a better approach, so we'll take a look at this one as well. So we're going to first find the LCM. Remember, that's least common multiple of the denominators. And this is of each part of the complex fraction. Of each part of the complex fraction. Then we're going to rewrite each denominator with the LCM. So rewrite each denominator with the LCM. Then we're going to multiply each numerator to make it equivalent. So whatever we need to multiply by to get the equivalent fraction, we're going to multiply by that. So multiply each numerator to make them equivalent. Then step 4, the denominators of your complex fraction are going to cancel out. Okay, so what we've just done is just get rid of the denominators, the fact that they're complex. So the denominators of the complex fraction will now cancel out. Meaning our final step is the numerator of the top becomes your numerator. And the numerator of the bottom That's right. Becomes your denominator. And obviously we'll have to add, subtract, and simplify as necessary. Okay, so let's go ahead and take a look at some examples of what that's going to look like. Okay, so pretty complex looking fraction, might be why they're called complex fractions. We're going to look for what our LCM would be. Okay, so LCM, we have an x, and we have an x minus 5. That is all the factors that are making up the denominator, so that's what we're going to go ahead and use. So what we'll go ahead and do is take our first part of this fraction, 6 over x minus 5. To get the denominator to match, we have to multiply by x, so we'll get x times x minus 5, and then 6 times x. And then we have plus 1 over x. This is going to become x minus 5 here and x minus 5 here. Okay, just making all of the denominators match. Divided by 3 over x. Multiply this by x minus 5, x minus 5. And then we have minus. And the 2 over x minus 5, that will become x and x there. Okay, so what we've just done is we have made all of the denominators match. And what I just said a few moments ago is that that means that all of these denominators now cancel out, and we're going to end up with the numerators becoming the new numerator. So 6x plus x minus 5 divided by 3 times x minus 5 minus 2x. Then we just simplify, combine like terms, and that'll be our answer. So we're going to end up with 7x minus 5, the numerator. This becomes 3x minus 15 there. So when we combine like terms, we're going to end up with x minus 15. And there is our simplified complex fraction. Okay, not too bad. Let's do another example. Okay, this one. We're going to go ahead and look for the LCM. So we have a 6, a 3, a 5, and a 10 in the denominator. So multiples of 6, 3, 5, and 10. LCM is going to be 30. So we're going to write these as fractions over 30. Okay. Now all the denominators match. We'll have to adjust the top though. So we have x, 6 times 5 gives us 30. So we're going to have 5x. 3 times 10 gives you 30, so we'll have 10x here. 5 times 6 gives you 30, so we'll have 6x here. And 10 times 3 gives you 30, so that'll be 21. There. Okay, the signs didn't change. Now, what we said was we can cancel out the denominators. The new numerator is going to be 5x minus 10x over 6x minus 21. Simplify that a little further. We get negative 5x over 6x minus 21. Okay, so we can see that this becomes a pretty quick way to approach this. Let's do another example here. Okay, looking for the LCM here. These are just over 1. So in reality, the LCM, least common multiple, is just x. So we're going to write these all as over x. which means that we're going to have 2 minus 4x and 2 plus 3x, put that whole as two fractions. This will simplify. Remember, the denominators now cancel out. So we end up with 2 minus 4x over 2 plus 3x. Okay, that one's done. Let's go ahead and do one final example. Okay, we've got to find our LCM. Okay, LCM, first step to these. We have x plus 5 is one of our factors, and we have x minus 3 is our other factor. So there's our LCM. Write the denominator, x plus 5, x minus 3. Denominator here, x plus 5, x minus 3. Write the denominator here, x plus 5, x minus 3. Yes, I know I'm repeating myself a lot. And then we go ahead and adjust the numerator so that they're equivalent. We end up with 3 times x minus 3. We have 2 times x plus 5. And then here we just have x minus 3. We had addition here in the middle. This whole thing is one big fraction. So again, the denominators cancel out, which is great. So what we're left with is just 3x minus 9 over 2x plus 10 plus x minus 3. We'll now go ahead and combine like terms. We get 3x minus 9 over 3x plus 7. There's our answer and our last example. I'll see you guys soon.